Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem, detonate the maximum bombs. Pretty hardcore for a Leetcode problem, but it's a pretty interesting problem. We're given a list of bombs and you can see for each bomb, we actually have three values. The first two are going to be the coordinates. So like the X coordinate is first and then the Y coordinate is next. So for this bomb, it is at an X value of 6, a Y value of 1, and then the third value in this case is 4. That tells us that from this point, we have a circle with a radius of 4. And it's not just, a circle, it's a bomb. So when this bomb detonates, this is the blast radius of the bomb. And we could have many bombs on our grid. We can see we have another bomb over here, and it looks like this one is just overlapping with that one. And what that means is if we detonate this bomb over here, it's going to set off the other bomb as well, because it looks like they just intersect. The origin of that bomb just intersects the blast radius of this one. And of course, you can imagine that we have multiple bombs. Maybe we have a bomb over here, we have some bombs over here, or maybe like a bomb over here as well. Now, what's interesting about this problem is notice how if we were to actually have detonated this bomb first, it would not have set off the other one because this one has a much smaller blast radius. It looks like just 3. So the good thing is the premise of the problem is simple. We just want to detonate a single bomb from any of the bombs that were given. And also when we set off this bomb and it triggers this bomb might set off some other bombs and those might set off some other bombs. So you can kind of imagine that this is really a recursive problem in nature. For us to set off one bomb and to count the number of bombs that were set off in total, we're going to have to kind of go about this recursively because one bomb sets off another, that could set off multiple bombs. So this really starts to feel like a graph problem, but it doesn't look entirely like a graph problem. Like the first thing you might be wondering is, given two bombs that are adjacent to each other, or just like a pair of bombs like these two, how do you know if they set each other off? Like what's the math formula to figure that out? Well, that's not like an insanely difficult part if you remember your math, but if you don't, it might be difficult for you. Remember that these two bombs are not necessarily going to be like on the same x-axis. Like in this case, it's going to be pretty simple to calculate the distance, but imagine if this bomb was actually centered around here and we have a bomb over here. How do we calculate the length of this? Well, it's really just a triangle problem. You take x squared plus y squared, which is equal to the distance squared. So that's like the formula we're going to be using. And when you rearrange that and solve for the distance, you get something like this, the x squared plus y squared, and then the square root of that. So we can calculate like this x squared by getting x1 minus x2 and squaring that. And we can get the y by taking y1 minus y2 and then squaring that. It doesn't matter which order we put x1 in and what order we put y1 and y2 in, because if you're squaring a positive number or a negative number, the result is going to be the same regardless. Remember, squaring a negative number like -1 is going to make it positive anyway. So that's not like the super hard part, but how do we set this up to be a graph problem is my question. Or how do we even set it so that we can even find like the solution to this problem? Because it's going to be easy for us to calculate the distance between every pair of points. That's going to be the easy part. Like I mentioned, we can do that in n squared time just by iterating over every pair of bombs. And once we have the distance between them, how do we know if one bomb can set off another bomb? That's my question for you. How do you know that? Well, if I told you the distance between these two bombs is 4, which it looks like it happens to be in this case, and I told you that this bomb has a blast radius of 4, do you think that this bomb can set off the other one? Yes, obviously it can. So we can just kind of compare that to the blast radius. But how does that help us build a graph? Well, for any bomb, like we don't know which bomb we're going to start at. So maybe in the brute force, we can start from every single bomb and see if I detonate this bomb, how many other bombs is it going to set off? Well, that kind of becomes a graph problem. And just like I showed you, we know if this bomb can trigger another bomb, perhaps we can take all of the bombs that can be triggered from each other and put that into a graph called an adjacency list. So for this bomb, all of its neighbors in the adjacency list would be all the other bombs that it can set off. Now, I just have one simple question about this adjacency list, and I'll let you answer it actually. Are the edges in this adjacency list going to be directed or undirected? Take a second to think about it, and honestly, just looking at this picture should help you out a lot because, like I said, from the first bomb, it cannot detonate this guy, but this bomb can detonate the other one. So of course, the edges are going to be directed. That's going to be very important for us to calculate the maximum number of bombs that we can detonate if we can only detonate a single bomb to start out with. So that's pretty much all we need to know to set up the graph for this problem and then solve it. And so to summarize, what we're going to do is build an adjacency list for each node, for each bomb. We want to know which bombs that it can set off, and then we're going to run a graph algorithm. You can run either DFS or BFS, I believe. But basically for every single node, we want to use it as the source of our DFS and then count how many other bombs we can reach from that starting point. Now, if we have n nodes in our graph, n bombs, we might have up to n squared edges. So a DFS is going to take n squared. And how many times are we going to run this DFS? Well, for every source bomb in the list of bombs, so we're going to multiply that by n again, and we're going to get an overall time complexity of n cubed, and I believe an overall space complexity of n squared, because again, that's the number of edges, the worst case for our graph. So now let's code it up, and remember, the first thing we want to do is actually build our graph. And remember, we're building an adjacency list where I'm just going to use a hash map, and I'm going to specifically use a collections.defaultDict, where the default value is going to be a list, because remember, for every node, or every bomb rather, we're mapping it to a list of bombs that it can detonate. So making this a default dict just makes it so we don't have to insert an empty array every single time we initialize a key in that hash map. So now to go through every pair of bombs, I'm going to say for I in range the length of bombs, and I'm going to do that again with a J pointer, but our J pointer is going to start at I plus 1 because we don't want to have duplicate pairs of bombs. And I should probably call this J. And first, I'm just going to unpack the coordinates and radius for each bomb. So I'm going to say X1, Y1, and R1 for bombs at index J, or index I probably first. And I'm going to do the exact same thing for the bomb at index J, except this is going to be radius 2, Y2, and X2. Next is actually calculating the distance, which, like I said, is not super difficult if you remember how to do it. X1 minus X2, and then square that. In Python, you can do that with double star, and then adding to that Y1 minus Y2, and then squaring that. And then for this entire thing, we want to get the square root of that, and that's going to be the distance between them. Now, like I said, the edges are going to be directed, so it's very important how you do this part. First of all, if the distance is less than or equal to radius 1, that means that the bomb that has this radius can detonate the other bomb. So basically, the bomb at index I can detonate the bomb at index J. So to the list, we're going to append I. We're saying I can detonate J. And we're going to do the exact same thing for the opposite case, where the distance is less than or equal to R2. That tells us that J can detonate bomb I. So basically the reverse. That's enough to initialize the adjacency list. Next, let's first show how we're going to use our DFS before we actually implement it. And by the way, I used the index for the key of every bomb because we can, of course, use that index to get the coordinates and the radius for every bomb. So that's what I'm going to be using as the key for our DFS. And what this DFS is going to do is, of course, count the number of bombs we can reach starting at I. So then, before I even implement it, I like to show you how I'm going to use it. So for I in range length of bombs, we want to use every single bomb as a source in our DFS. So as a starting point. So we're going to call DFS starting from here, and we want to ultimately store the maximum number of bombs that we can detonate. So result is always going to be set to the max of itself, or the recursive DFS call. Now we're getting pretty close to the correct solution. Out here, I'm going to return the result. Now all we have to do is actually implement our DFS. The most important thing about DFS is the base case. We don't want to visit the same node multiple times. The only way we can know that is by using a data structure like a hash set. So the first thing I'm going to do here is say for if I is in visit, which is going to be a hash set, and it's also going to be a parameter to this DFS, And where am I actually going to create it? Well, I'll just create it as we call the DFS, so creating a new hash set down here. The reason I'm doing that is because every DFS is going to need a new hash set, so it's good to create a new one every single time. And of course, if a node has already been visited, a bomb has already been visited, we can return 0 because we can't, of course, detonate any more bombs in this direction. Otherwise, we say visit.add this bomb, and then we go through every neighbor of this bomb, which we can get from our adjacency list. That's why we built it in the first place. So for every neighbor in the adjacency list, we're going to call DFS on that neighbor, passing in the exact same hash set. You might think, aren't we going to try to total up the number of nodes that we can visit? So maybe I can have another variable result here and then just add to it every single time. That might work as well, but we actually have an easier thing that we can do. Remember, we're keeping track of all the nodes that we visited in the hash set. So why not, by the time this is over, just return the length of that hash set. And the only time we're actually going to use the return value here is not going to be anywhere inside of the recursive calls, because you can see here the return value is not being used. We're only going to use that from the root DFS call, which is where we would want to use it. That's going to tell us the total number of bombs. So it looks like things do work out for us. So this is the entire code. Now let's run it to make sure that it works. And as you can see, yes, it does, and it's pretty efficient. If you found this helpful, please like and subscribe. If you're preparing for coding interviews, check out leetcode.io. It has a ton of free resources to help you prepare. Thanks for watching, and I'll see you soon.